Bem-vindos ao nosso espaço, um mergulho profundo nos assuntos mais interessantes de esportes, ciências e temas gerais do momento. Aqui você vai encontrar conteúdo de qualidade, com análises empolgantes e descobertas fascinantes que vão expandir seus horizontes. Nossa missão é trazer informação relevante de forma dinâmica e descontraída. Queremos que você faça parte dessa jornada incrível de conhecimento e diversão. Se gostar do nosso conteúdo, não esqueça de deixar seu like e se inscrever no canal para não perder nenhuma novidade. Ative o sininho também. Aproveite!
If you love science, don't forget to like and subscribe. Imagine taking a handful of fine, dusty soil, not wet dirt, but dry, granular powder, and squeezing it gently. On Earth, nothing much happens. The dust compresses, but it won't fuse into a solid brick. Now, imagine taking that same handful of soil, specifically the loose, gravelly material called regolith found on asteroids and the Moon, and performing the same action in the near-perfect vacuum of deep space. Suddenly, that loose dust binds itself together, forming a permanent, solid structural connection. It has self-welded. Welcome to the vacuum forge, where the lack of pressure and the purity of the void turn space dust into a building material. This phenomenon is called cold welding, and it's one of the most bizarre yet critical concepts in space engineering. At its heart, cold welding is the process by which two pieces of the same, or even different, metal fuse together simply by being brought into contact under pressure, without the use of heat or filler materials. On Earth, cold welding is difficult, often requiring massive force and highly specialized, controlled environments. The reason? The omnipresent enemy, oxygen. When we talk about metals on Earth, steel, aluminum, titanium, they are almost instantly coated in a thin layer of oxidation, known as the oxide layer. This chemical barrier, usually just a few atoms thick, acts as a contaminant, preventing the metallic crystals of one surface from ever directly contacting the metallic crystals of the other. It's like trying to glue two panes of glass together when both are wrapped in cellophane. The glue sticks to the cellophane, but the glass never touches. In the environment of an asteroid or the Moon, the rules change fundamentally. The vacuum is not just good, it is virtually perfect. Without an atmosphere, there is no free oxygen to spontaneously form that protective oxide layer. The metallic elements and silicates present in the asteroid regolith remain pristine, their surfaces, naked, and hyper-reactive. This is where the physics of atomic bonding takes over. When two pure, clean metal surfaces are pressed together in a vacuum, the atoms on the two interfaces don't recognize the boundary between them. They are essentially identical crystal structures, and the electromagnetic forces holding them together, the metallic bonds created by shared electron clouds, snap across the gap. The two separate pieces instantly become one monolithic structure. This isn't just sticking. This is true welding at the atomic level. Asteroid regolith is the perfect raw material for this process. While it's composed primarily of silicates, it also contains significant amounts of iron, nickel, and other metals, especially in C-type or M-type asteroids. These angular, often sharp-edged dust grains, when subjected to external compression, even the relatively low pressure generated by a simple compacting device, have their pristine, metallic surfaces brought into contact. Think about what this means for future space construction. If we want to build large habitats, shielding, or complex infrastructure in orbit or on the Moon, transporting materials from Earth is prohibitively expensive. Every kilogram costs tens of thousands of dollars. The vacuum forge offers an elegant solution: in situ resource utilization, or ISRU. Future robotic systems could land on an asteroid, scoop up the regolith, and utilize specialized compactors, essentially high-pressure 3D printers, that simply press the dust into the required shapes. The intense vacuum does the rest, instantly forging walls, beams, and interlocking components without the need for energy-intensive heat, massive chemical binders, or complex atmospheric control. We are not melting the material. We are forcing its fundamental structure to synchronize. This technique isn't just theoretical. NASA and aerospace research groups have been investigating cold welding extensively, not only to utilize it but also to prevent it. Ironically, cold welding is a significant hazard for spacecraft. where moving parts like gear trains and latches made of pure metals can accidentally fuse together if the lubricating boundary layers wear off in vacuum. But what is a hazard for a machine on Earth orbit is a revolutionary manufacturing opportunity on the desolate surfaces of the solar system. The vacuum forge transforms the concept of space mining from simply extracting resources to manufacturing resources right where they are found. It turns asteroid dust, previously considered worthless filler, into the foundation of our off-world future, proving that sometimes the greatest forge is the absence of everything. For more incredible facts like this, don't forget to subscribe and turn on notifications.